All right, so in the next one, we are going to be looking at this weird circuit to the right. It's a little bit more complicated with some different resistors. We've got a couple of batteries facing opposite directions. It's going to make things a little more confusing, but I will tell you right now that using Kirchoff's rules, it's going to be very, very manageable. All right, so we're going to find the current and the potential difference across each resistor. So in order to do that, we are going to need to figure out first the current. Now, because it's a little bit weird and confusing, Kirchoff's rules is a good thing to do. So remember, with Kirchoff's, we do need to identify the direction of the current. So I'm just going to say that it looks like the current's going to go this way because I feel like the 9 volt is going to overpower the 6 volt. Maybe I'm wrong, but that's going to be my initial guess. So I'm going to start right here as I go through the 9 volt. As I go from negative to positive, what that means is that my process, I'm gaining 9 volts there, right? If I continue around the circuit, now I go through the 4 ohm resistor in the direction of the current. And so since I'm going in the direction of the current, then I expect to lose 4 times I. Remember, V equals IR. That comes from that I equals V over R multiplying by R. So that V equals R we're going to use a lot here. So minus 4I, because I expect to lose some potential as I go through that resistor. Then I'm going to go through the 6 volt battery here, but notice I'm going from the positive side down to the negative side. Now what that means is that I'm actually going to subtract 6 here because I had a higher potential on this side and a lower potential on this side. Now what the actual values are doesn't matter. What matters is it goes from some value and then it's 6 less than it was. So I'm going to subtract 6. Now I'm going to continue through the 2 ohm resistor. Again, I am going in the direction that I identified as my positive current. So that's going to be a minus 2I. And then at this point, I return back to the point I started at. And so now I can just say that is equal to 0. Hopefully at this point I can now solve. So I'm going to put the 9 and the minus 6 together. That'll give me 3. Put the minus 4i and the minus 2i together. It gives me minus 6i equals 0. I subtract the 3 to the other side. I'm going to have negative 6i equals negative 3. Divide both sides by negative 6, and I get a current of 0.5 amps. Now, if you ever get a negative, that's fine. That just means that the current is actually going opposite the direction that you chose. In this case, that's what I get, that the current is 0.5 amps. Now, there was only one wire here, right? So I didn't have to worry about it splitting up. I didn't have to worry about multiple currents, anything like that. I just went straight to Kirchoff's second law, which is that idea that in a loop, the sum of the potential differences have to equal 0. All right, now it did ask for the potential difference across each resistor, so we are going to use this idea of I equals V over R, or simplified V equals IR for each resistor. So the potential difference across the 4 ohm resistor is going to be the current, which is 0.5 times the resistance, which was 4, and I end up getting 2 volts. And then I'll do the same thing for the potential difference across the 2 ohm resistor, which will be 0.5 times 2, giving me a total of 1 volt there. And so I've answered the question about the potential difference. Notice that if I gain 9 in the battery, I lose 2 volts here, lose 6 volts here, lose 1 volt here. That means I'm back to 0 again before I go through that 9 volt battery. Okay? Now in letter B, it wants us to draw a graph. So this is interesting. It wants to draw a graph showing how the potential changes around the circuit. We're going to start with V equals 0 at the negative terminal of the 6 volt battery. So let's go ahead and create a graph. All right, now let's see what we can come up with here. All right, now the first thing that it says that we're going to start at 0. So I'm going to start at 0 here. And then it says on the negative terminal of the 6-volt battery. So we're starting here, and then we're going to follow the direction of the current. So we're going to go this way, and we're going to go through the 2 ohm resistor. Now remember, in the 2 ohm resistor, we lost 1 volt of potential. So we did stay at 0 for a little while. So I'm going to just show that I stay at 0 for a little while. As I go through the 2 ohm resistor, I need to go down to -1 volts. And then I'm going to go through. I'm going to be at that value for a little while. And then I'm going to go through the 9-volt battery. I'm going to go from what I was at, which is -1, all the way. I'm going to increase by 9 volts. So I've got to go all the way up to 8 here. So from here, I'm going to shoot up to 8 volts right there. And then I'm going to go through the 4 ohm resistor. And so after a little while, I need to lose 2 volts. So I'm going to go down to 6 there. So I go down to 6. Then I go 0. No change for a little while. So stay at 6. And then I'm going to go through the 6-volt resistor, which is going to drop me right back down. It should drop me 6 volts. I'm at the 6 right now. I go down to 0, and therefore I'm back to where I started from again. So your graph should look something like this. It doesn't have to look exactly like this, doesn't have to be perfect, but the idea of starting at 0, going down to -1, going up to +8, down to 6, and then back to 0 again, that's exactly what we're looking for. All right?